Hello, viewers. For the Johns Hopkins University Whiting School of Engineering, Engineering for Professionals, Master of Science in Computer Science program, it is the A Team's Clueless Product Demo. Withstanding team project struggles, in our beliefs, we want you witnessing a successful product demo. Our team members are the following: Anthony Mora, he led software development efforts. This included Python, JSON of JavaScript object notation, and GitHub. He also contributed to the software architecture implementation using client server communication scripting. Naila Mulati, she led quality assurance efforts. This included communication platform initialization and document production efforts. She also contributed Python programming. Rem Houghton, he contributed significant programming and development assistance. Fritz Wesselhoft, he led the hardware architecture and software architecture efforts. Myself, Jonathan M. Kelly. I am our team's project manager and systems analyst. In a non-standard role, I gave project management recommendations, but when appropriate, I offered isolated role communications. Plus, I attempted contributing a software development solution, and with Naila Mulati, it worked out successfully, as well as from the help of Anthony Mora. From each role representative, our product required dedicated effort, but we all contributed substantial efforts to the planning, design, and testing. The development's major contributor was Anthony Mora because a starting decision was using Python scripting, and he was most experienced in Python. In fact, our product demo's GUI of graphical user interface was contributed to by Anthony Mora. As you shall soon witness, we have put our love into this work. On work discussion, I want you, viewers, understanding the target and increment work done, the GUI of graphical user interface, the music, and class quality measurements. To begin, the GUI of the graphical user interface, this increment contained had movement and a notepad scheduled, but these required a greater critical path than this course, Foundations of Software Engineering, permitted, and we implemented the design to schedule project method. Thus, the movement is TUI-based. Of text-based user interface, that is, the buttons are experimental. Plus, the notepad is TUI-based, that is, within the minimal increments TUI scope, the notepad meets our goals. Further, added music is open source, free stock, and royalty-free. This reduced overhead. Furthermore, while steady programming progress encouraged class enhancements, reduced errors encouraged function encapsulation. In turn, this proliferated script reusability and improved script reliability. Next is Rem Houghton, who shall discuss the SLC of the software lifecycle.
Hi, I'm Rem. One of the biggest successes of the project for us was figuring out how to bring together in one project a lot of the concepts we covered in our lectures. While all the concepts played a role, we especially benefited from giving more deliberate thought towards our choice of lifecycle, our requirements engineering, object-oriented analysis and design, and our testing approaches. We opted early on to try to follow a design to schedule model. Throughout the project, referring to this model helped us organize our workflow and prioritize the work we needed to get done. Additionally, learning the important aspects of requirements engineering led to much more concrete and comprehensive objectives for us to aim our project towards. While object-oriented design wasn't unfamiliar to anyone on the team, adding extra emphasis on this approach to structuring software helped us think through how to solve a larger problem in an organized and sustainable way. While we haven't been able to test the final product as much as we would have liked, we opted to implement tests earlier on than maybe we typically would have, and this really helped us minimize a lot of error amplification later in the project. Overall, learning how to incorporate these ideas in a collaborative environment drove a lot of the progress in the project and feels like a great outcome. Next, Naila will talk about the validation tests.
Thank you, Ram. So we did few validation tests. First of all, we did client-server connection testing, and it has been working perfectly. And players are able to start the game, able to move around the rooms, take turns, make suggestion and accusation. Unfortunately, we were not able to incorporate suggestion, accusation, and moving functionality into our graphical user interface. The reason was, since the game operates in a type of infinite loop, we were having trouble redrawing the new updated frame each game cycle so that updated information was displayed to all players. For example, all the game data was being sent to all the players in the background, but adding the corresponding graphical user interface elements to match the data being transferred was more difficult than we thought initially. Especially difficult was the suggestion functionality, since many new frames needed to be drawn for a single player's turn. But the good news is, in our later demo, we will present you with a mock-up of the graphical user interface and what we would have liked to see in implementation, with a very cool background music we were managed to add into our game. Next, I will hand over to Fritz to discuss about what could have been improved and the lesson learned.
Hi everybody, my name is Fritz Wesselhoft and I will talk about what could have been improved. I have broken this slide into different areas: improvements for this project and improvements for real-world projects. I will start by talking about the formal testing procedures, adding more testing activities in early phases of the software development lifecycle, starting as early as during the requirements phase, would have been extremely beneficial for this project. Also, it would have been great to add more dynamic and static testing procedures to our program. We could have done this by creating an extended list of test cases and applying the corresponding unit testing, regression testing, or any other tests that could have helped us finding issues early during the development phase. Another requirement that we could have improved is our graphical user interface for the game. We built all the logic required for all the scenarios, such as moving, making accusations, making suggestions, the messages between the clients and the server, and everything else is working as expected, but making that switch between text-based and graphical and adding the graphical user interface was a little bit tricky, and it made it difficult for us to fully implement it. Next, I will talk about improvement for real-world projects. For instance, an application or a game that you're building for your job will have extra requirements besides for what we cover for this project. For instance, we will need to add security. Security is fundamental nowadays for development of applications. It is considered to be extremely important to add security from the very beginning of the software development lifecycle. So for a project like this, a few things that we could have added to enhance the security of the application would have been using SAST or a static application security testing, also DAST, which is dynamic application security testing. Especially SAST, that's something that we can add as early as during the coding phases. So generally you can add a plugin on your IDE. So while typing, you can get a feedback on any security vulnerabilities or bugs that you could have been adding to the code without even knowing it. This is fantastic because it helps you finding these issues really early. As we have learned during this course, the earliest you find these problems, the easiest and the less expensive it becomes to fix them. Another security feature that we could have added is authentication. So not everybody can connect and log in. It will require either a username and a password or some other form of secret that needs to be added in order to log in and authenticate into the game. Another security technologies that we could have added to this project is using a security information and event management system, for instance Splunk. It would have helped finding issues not just in security but also in operations. But it is a fantastic tool for security as it helps on investigating in real time logs and sending alerts based on different logic or requirements that the game may have. We could have also added an intrusion detection system either on the servers or on the network, among many other security capabilities that could have been added to this project. Another feature that we could have added is availability. As we all know, availability of your application or of your game is extremely important. Nowadays, if your game is not reachable, if your application is not reachable, the player or the client will just go to the next person. So you will probably lose clients or will lose money. Either way, it's not good for business. So availability is very important. For this implementation, we leverage AWS for our game server architecture, and we could have used other AWS services to help us with the availability as well. For instance, we could have used auto-scaling groups. AWS auto-scaling groups is a fantastic way to scale your number of servers, either up or down, based on whatever threshold you want. For instance, you can have a rule saying, hey, if we reach 70% of CPU utilization, it means that probably I have a lot of people connecting to my game, so increase my stack. So what happens is auto-scaling group will detect the threshold and it will increase the server count. Once that threshold stabilizes, maybe a few players finish the game and they log out, and the CPU reaches the lower side of the threshold, then auto-scaling will kill the previous server. So you're always using what you need, no more than what you need. And this is fantastic for availability. We can also leverage auto-scaling groups with a load balancer. On load balancers, we can use health checks. So for instance, if your health check fails, it basically means that you're having a major problem on your server, either a physical problem or some other kind of catastrophe on the server. That will probably take a lot of time to fix and troubleshoot. So you can use health checks operations in the load balancer to kill your instance. If the instance is not healthy, just kill it, bring another instance up. And this happens behind the scenes, and you won't even notice that the servers went down. Also, the clients and the players will also not notice this. So it's a great way to keep your your game players happy, or your clients connected to your applications. Finally, I will talk about monitoring of operations. This is coupled with alerting usually. So before we talk about some of the capabilities that could have leveraged AWS for availability, the same is true for monitoring and alerting of operations. So AWS services offers something called CloudWatch. So CloudWatch is a great way to monitor the health, the performance, and the overall operational metrics of your applications or your containers or your databases or your servers or any infrastructure that you may have running in AWS. These metrics thresholds can be combined with other services such as SNS to receive notifications via text messages in case something happens. Also we could use SES to alert via emails, again, in case any of these metrics reaches a threshold. Or we can even use Lambda functions. So you can say, like, for instance, you can have a metric saying if you get like X amount of TCP probes on your server, that probably means that something fishy is going on. So you can have this metric to deploy or to launch a Lambda function, which is basically a program that can ingest the information from the event and perform an action. For instance, reroute the traffic to the firewall, or stop the traffic completely, block the port, and anything else that you could do with the program. So it is extremely flexible and it's really easy to use. Well, with this, I will conclude with this section. Next, let me introduce Anthony Mora. He's going to go over the game demonstration.
Hi everyone, my name is Anthony Mora and I'm going to be demoing our final Clueless application. So in a second here, you'll see me running the game script on 3 different terminals, which then starts the game. We decided to give the game a dark theme and added a bit of background music to enhance the user experience. The join game button cannot be pressed until the user enters their name and hits enter. Once the join game button is pressed, the user is taken to the waiting lobby. Now I will be entering 2 other players to start the game. Normally this would be done on each person's laptop computer. As soon as enough players have joined, the game will automatically start. So this is how we decided to lay out the user interface. You can see the game boards right in the middle and various other drop-down menus on the left side. You can also see your player on the top left corner and your cards on the bottom of the screen. The status of the game is maintained in the upper right hand side, and the extra space on the right hand side was going to be used to implement the player's detective notepad. Unfortunately, we ran into some time management issues and were unable to implement the suggestion, accusation, and moving functionality. However, this is what the end product would have looked like. Since we weren't able to complete the final increment, I will be demoing our finalized minimal increment. What you see on my screen now is the finalized minimal increment. I have 6 terminal windows open, and I am running the server script on one of them and the game script in the other 5, entering our names as the players' names. Once enough players have been connected, the game will start. As you can see, the player who is playing as Miss Scarlet will go first. So for now we can just say make an accusation, pick a suspect, a weapon in a room, and follow the suggestion functionality. As you can see, we are also now presented with adding a note to our detective notepad. Each player has their own notepad and can add notes and see their notes during their turn. The game will then continue to the next player, who decides to make an accusation. On the top left of my screen, you can see the correct winning cards. Obviously, these cards will be hidden from the players in the actual game. But for now, you can see that I have made an incorrect accusation with that player, and he or she is no longer in the game, but will be maintained to disprove suggestions. The game then continues until we get back to the first player, so that we can see that his or her notes are still in the detective notepad. We can see here that they still are in the notepad, and we could actually add another note, which we will do. For now, we'll just say player 1 second note. We can see that the second player's turn is skipped because he or she made an incorrect accusation in a prior move. The next player decides to make another suggestion, so he or she picks an arbitrary suspect, weapon, and room to try and figure out some clues to the game. Also note that the suspect who is picked during a suggestion is moved to the location that the user has picked. So in this case, the player who made the suggestion has picked the study, and the suspect who was picked will be moved to the study. The game then continues on until one player has either made a correct accusation to win the game, or enough players have made incorrect accusations and there only remains one person left, which will become the winner by default. Here is just more gameplay. You can see pretty soon one of the players will make a correct accusation by using the small hint that we currently have while testing this game on the top left of the screen. Once that player finishes the correct accusation, everybody is notified that someone has made a correct accusation and the game ends. We thank you all for watching our demos throughout the semester, and again, apologize for not being able to complete the final increment. Thank you.